In this video I will demo the feature of the power velocity controller. It's called charger mode, and it allows you to charge battery using the controller phases and a motor that's connected and used as a large inductor to boost the voltage from any lower voltage of the battery, the target charge voltage, to the required voltage. So basically it allows you to charge from any DC source that is lower than your battery voltage, maximum battery voltage. So here we have our setup, and I'll just talk a little bit about that, what we have. So we have the controller, which is on currently. We have the gauges currently showing 90 volts, and that runs through the current shunt. We also have the amp meter, and we will be able to measure the input current that goes into the controller, and that current gets boosted, voltage gets boosted through the motor to the required voltage to charge the battery, which is 90 volts in this case. Actually, we'll be charging up to 95 volt for this battery. So now the software part, we're using a VESC tool, and it has something that we developed, the application that allows to use the controller in charger mode. So right now let me talk a little bit about the settings here. So charger mode is basically tells you if it's on and off, and this is, by the way, is the terminal. Can be controlled through Bluetooth, through pretty much any way communication protocol is supported. Right now I'm just using the terminal to demonstrate this. So charger mode, then charger, if it's on or off. CC is a constant current, and CV is a constant voltage. Those are two modes that are required for lithium-ion batteries. So that's the channel, PWM channel used, which is the phase number 3 in this case. For this controller, the frequency is a little bit error there. It's not megahertz, it's kilohertz. That's the maximum frequency that the charger will run on. And then duty cycle, will show you real time what the duty cycle is when it will run. That's basically all debug information, WPM, how many instances of modulation are there, just the number for debugging. Battery is that's the current battery reading, which is what we saw here, about the same voltage. So it's just monitor the voltage battery as it gets charged. Current, it gets a little bit off right now, but let's see, update it. Here we also have other more technical things. We're not going to talk about them, coefficients. So then there are target battery. It's a target battery target current for the battery. So you can set up, right now it's set up at 4 amps for this test. And then the charger calculated, that's basically the algorithm will figure out the best current to charge at. And then there's a maximum charger, the DC source current, where you can limit to prevent pulling too much current from the DC source. If, for example, if it's doesn't allow you to pull, just limits that current that you can pull it. Then you can set up the target battery voltage, which is, I set at 95 volt, and we can also read the MOSFET temperature and motor temperature. And the last setting is auto start charging. Basically, when you connect the charger, it will start charging immediately. So that's what that feature is. So all these settings can be configured and saved to EEPROM in the firmware, so you can configure them once and forget about it. So it will charge automatically as soon as you connect, and I'll show you how it's done. So right now, so what I'll do, so it's already all connected, but I can change these settings if I want, but I don't really need, it's already set up. So what I'll do, all I do is just take this and connect to one of the phases. So it's connected now. So what's going to happen is that the way I know that it's charging, it starts PVMs. It opens up the phase, so it starts to the booster starts to work. So right now I'm seeing negative current of 3.4 volts, and it's still ramping up. The reason it's not ramping up all the way is that I limited the input current, and the input voltage is around 30 volts. So what happens is that it boosts the voltage 3 times, technically, to all the way to 90 volts from 30 volts. That's why on the input we get around 11, and that's the limitation. I actually set it to 10, but it's pulling just a little bit due to the error margin. So what happens is that it is limited it to 3.2, but it keeps it at that safe level. So it's getting the current, right? So this is what happens if I disconnect, right? So it drops. I'm not going to connect, and I'll show you how it actually ramps up slowly, for, to prevent any sparks or anything. So I connected it, but it did not immediately start to charge. What happens is that it slowly ramps up the current to make sure that it's safe. So it may go a little bit higher, overshoot a little bit, but then it slows down and drops it to the safe levels, right? We have around 30 watt going into the battery, which is what this power supply can really output. I'm not gonna overload it, but it's probably a little bit hot already. Let me see. Yeah, it gets a little bit hot. But this is just for a test. So this works. It works pretty well. So any DC source can be used as long as its voltage is lower than the target battery voltage. It will run well. So let me show you. Here's something what happens here. So it is working. So I'm gonna update the data and see what is happening here. So duty cycle is around 67%. So that seems good. That's the target battery voltage. However, it is charging the current. It is measuring is 10 amps in. Let's see the temperatures. So MOSFET temperatures is 35, and the motor temperature is 24. The feature that this algorithm has is also it's monitoring the temperature for the motor. So when you run the current through the motor, obviously it gets warmer or hot eventually, so we want to make sure we don't kill the motor or overheat the motor. So the temperature will use basically the same monitoring. Will use the monitoring in VESC to prevent motor overheat. It will roll down or stop charging if the motor temperature goes too high. So what else? So this works well, so one of the thing I'm going to use for this is just this flat pack with a really nice small DC source used in telecom communication. I can use it for up to 250 volt, but it will work from 120 volt, no problem. And it can output 53 volt 0.5 at 33 amps. That's a lot of amps. I will have to charge this battery, or pretty much any battery I have, starting from 72 volt or 50, 48 volt up to whatever 150 volt. No problem. I can charge pretty much anything from just this one, and it's pretty light. So this provides me with up to 1800 watt of power, and that will charge any battery pretty much pretty fast, and it will output more than the battery can handle probably in charging current. So that's about it, and that's the demo for the charging mode on power velocity controller. Thank you. See you next time.